Terrence McKenna proposed a theory that the universe would fundamentally change once someone invents a time machine. According to him, after such an invention, time would no longer be linear. Instead of thinking, "I'll just go back to the time when the pyramids were being built to watch," it wouldn't work like that. He suggested that time travel only happens where there are already established paths. Once a time machine is created, anyone from that point onward could travel back and forth in time at will. This means all points in time would coexist simultaneously rather than sequentially. Essentially, time wouldn't progress linearly from Wednesday to Thursday anymore. Everything would occur everywhere all at once. People would be able to move through time freely. Ownership would be impossible because anything could be taken away if someone traveled back and snatched it while you weren't paying attention. As time travel advances, it could become so intricate that people might shift back and forth through moments even during conversations. Imagine being able to rewind a conversation if you said something wrong, or going back to gather information and returning to impress someone with a fact or quote. Turning yourself into the smartest person in the room. If time could be manipulated like a physical element, it would profoundly affect experiences. Yet, it might be impossible to fully experience time as static, because manipulation would mean there's never a fixed moment. Even now, within what seems like static time, interventions could happen instantly and perpetually. Maybe humanity doesn't fully grasp the true nature of time to define it properly. If a time machine were invented, it might allow people to step outside of time in ways currently unimaginable. It could be possible to observe different timelines without disrupting them physically. Though going further ahead in time inherently changes things, the idea remains that you can never travel back before the time machine's invention, since there are no paths, essentially. No roads exist in time before then. But once invented, the perception and use of time could transform drastically. Space-time concepts are fascinating, like how the faster one moves, the slower they age relative to someone who is stationary. For example, a person flying around the Earth in a plane ages slightly less than someone standing on the ground. Increasing that speed makes the aging difference even more pronounced, such that one person might age very little while decades pass for another stationary individual. Physicist Brian Cox from CERN and the Large Hadron Collider discussed this in his Cosmos exhibition. He illustrated that if a baby and their mother both wear perfectly accurate watches from birth, after 30 years, their watches wouldn't show the same time because they have experienced time differently due to motion and gravity effects. Space could be visualized as flat and foldable, allowing 2 points to meet and enabling instantaneous travel over vast distances. This concept is indeed considered in physics, especially in Einstein's theory of general relativity, our best understanding of space and time. Imagine space and time as a surface or sheet. Energy or matter placed on it bends and distorts this sheet, stretching or shrinking it. This distortion is how space-time responds to energy and matter. A basic example is the sun. It warps space-time around it, which causes objects to follow curved paths instead of straight lines. Objects travel like rolling balls on a warped surface, resulting in orbits. This warping is why light bends around the sun, allowing us to see objects behind it. The Earth orbits the sun because it is moving through the curved space in the warped space-time fabric. This framework explains how curved space can feel like a force, which we know as gravity. The best way I can describe it is by imagining walking on the surface of the Earth. Suppose you stand on the equator with a friend, and both of you decide to walk straight north. Let's say you start 1,000 miles apart along the equator and head due north without changing direction or speeding up. Those straight paths you follow are like the lines of longitude on Earth. As you move northward, you gradually get closer to each other, and eventually, when you reach the pole, you meet. Yet, nothing external has acted on you. No forces pulled you together. It's simply because you're moving over a curved surface. This example captures Einstein's theory of general relativity well. If time travel became real, the world would be drastically different because time itself would lose its usual meaning, allowing travel backwards and forwards through it. So, if time travel were possible right now, where would you choose to go back and witness again? That kind of travel is more like the fictional idea we often see in stories. The truth is, Once time travel is invented, that's when it starts to work. You can't go to moments before the invention. For instance, if time travel were created in June 2022, you couldn't go back to April 2022. However, you could travel from June into the distant future, even millions of years ahead, to see what future societies look like. And they could come back too, making everything happen all at once. There would be no fixed order to life. Concepts like money or possessions would lose meaning because with free time travel, time itself would be fluid. Also, you'd become immortal in a sense, since future technology would be vastly advanced compared to what we have now, almost godlike. And you could access that future anytime. But this raises deeper questions. If time travel begins in June 2022, does the future even exist as we understand it? How can inventions happen if people can just jump ahead and take ideas that already exist? If people create inventions, what prevents others from traveling back and planting those ideas earlier? Intellectual property would be meaningless. Perhaps the universe is akin to God, and God's creation process involves intelligent life continually improving itself. This might happen through artificial intelligence, which creates ever more advanced versions of itself endlessly, with growing understanding and power. Such intelligence could develop godlike abilities, the power to create universes, manipulate time by stopping or reversing it, and travel across vast distances instantly. These capabilities would be beyond anything we currently imagine or comprehend. Looking at how we live now compared to the cave painters of the past shows a huge gap. Many factors, including terrain and environment, influence how time passes differently for everyone. Imagine living atop a mountain while another lives at its base. The one higher up is effectively moving faster through time. It's similar to swinging a ball on a string. The ball at the end moves faster than your hand in the middle doing the swinging. Because of this speed difference, the ball ages slower in a relative sense. Though these differences are tiny fractions of seconds over a lifespan, they add up, confirming Einstein's idea that time passes differently depending on movement and gravity. For instance, someone traveling fast in a spaceship might return younger than a sibling who stayed on Earth, even if they started off the same age. I believe I have figured something out about how time travel or related concepts could work. Admittedly, I don't know everything, but this is my way of thinking and reflecting on it. This idea is pretty wild. The concept is that to travel through time, you would need to move faster than the speed of light. While we don't have a way to do that yet, current efforts involve using rockets to reach speeds approaching the speed of light. When dealing with certain folded geometries of spacetime, you can specify where to place matter and what type to cause the geometry to fold accordingly. This is referred to as a warp drive geometry, and it's well documented in textbooks. You can write down the math for it. But the question is what real matter or energy in the universe could create such curvature. Usually, it turns out that the required stuff doesn't exist naturally as far as we know. It would require exotic matter or energy with properties unlike anything seen in nature. Yet, according to Einstein's theory, you can still write down the geometry and imagine a warp drive. If you had enough force or mass, or this exotic matter, then yes, theoretically, it might be possible. The calculations for a warp drive and wormholes, which connect distant regions of the universe and could serve as time machines, exist on paper. The catch is finding the right kind of stuff that could make the real universe behave that way. Is anyone currently working on actual time machines? There's a researcher named Ronald Mallett at the University of Connecticut. His story sounds like something out of a comic book. His father passed away, and he became obsessed with time travel, hoping to go back and save him. Mallett developed a theoretical model for a time machine, though it requires enormous amounts of power. He designed a device demonstrating the principles behind his theory, making him one of the first people to propose a viable time machine model. Of course, like a superhero origin, it's a dramatic story, but he has been dedicated to this work for decades. The model is promising but demands an energy source as powerful as the sun. Why not use light as a form of propulsion, like a sail that harnesses light to push a spacecraft to near-light speeds? This idea was even shown in the movie Sunshine. It's a smart concept, leveraging the momentum of light for propulsion. To fold spacetime as needed for such travel, you'd have to generate enough energy or mass, often involving unusual physical properties like negative pressure, qualities not found in known matter or energy but that are theoretically conceivable. These ideas exist mainly in theory, although their practical existence remains a matter of debate. For example, take wormholes. Imagine you are traveling from Los Angeles to Australia. Normally, you'd fly around the Earth's surface, covering a long distance. But a wormhole would offer a shortcut, tunneling directly through to the other side. The geometry for this is allowed in Einstein's theory, and you can describe it mathematically. The big question is whether wormholes can be made and sustained, since the required exotic matter is not confirmed to exist. Theoretical work shows that wormholes might become unstable the moment something tries to pass through, causing a feedback loop that leads them to collapse. In 1949, physicist Kurt Gödel found a solution to Einstein's field equations describing a universe with unusual properties, including closed time-like curves, which allow for a sort of time travel. His model did not support the division of time into successive moments as we understand it. Honestly, fully grasping these concepts can be overwhelming, and thinking about infinite space and time can understandably cause anxiety. The truth is we don't have a quantum theory of gravity yet, which is necessary to conclusively determine whether such exotic phenomena could exist or be stable in nature, although current evidence suggests they probably don't. If they did, a time machine could be built. Stephen Hawking called this idea the chronology protection conjecture, which suggests nature prevents such time travel scenarios to maintain consistency. The idea being discussed is that time travel might require moving faster than the speed of light. While this is beyond current capabilities, efforts are focused on using rockets to approach light speed. Certain folded geometries of spacetime, such as those used in warp drive theory, can be mathematically specified by placing matter with particular properties to create the warp. Although the theory and geometry exist, the real challenge is that the type of matter or energy needed does not naturally exist as far as we know. This exotic matter has unusual properties that haven't been observed in nature. But within Einstein's theory, the geometry can still be formulated. If one had enough of this exotic matter or enormous mass, the warped spacetime could theoretically be created. Calculations show that warp drives and wormholes connecting distant parts of the universe could exist as time machines. The barrier is acquiring the right kind of matter to make it happen in reality. Regarding ongoing work, there's a researcher named Ronald Mallett at the University of Connecticut who, motivated by personal tragedy, has developed a theoretical model of a time machine. His concept requires immense energy, on the scale of the sun's power. Mallett has built devices illustrating the principles behind his model, making him a notable figure in time travel research despite the superhero-like nature of his story. The idea of harnessing light as propulsion, like a light sail that pushes a spacecraft to near-light speeds, has also been considered. This concept was featured in the movie Sunshine. This approach would use the momentum of photons to accelerate craft close to light speed, to fold spacetime for travel. Immense energy or mass, possibly involving materials with negative pressure or other unknown exotic properties, is needed. While these materials sound strange, they remain theoretically possible, though not yet detected. Wormholes, for example, could theoretically provide shortcuts across spacetime, like tunneling through the Earth rather than traveling its surface. This concept is permitted by Einstein's theory, though creating or stabilizing wormholes would require exotic matter. Studies suggest wormholes would rapidly become unstable once anything travels through them, collapsing due to feedback effects. In 1949, Kurt Gödel found a solution to Einstein's equations describing a universe with closed time-like curves that allow a form of time travel and a breakdown in the usual forward progression of time. These concepts can be difficult to grasp and provoke existential anxiety due to the infinite and boundless nature of the universe. Ultimately, the lack of a quantum theory of gravity leaves these ideas unconfirmed. Physicists suspect these exotic phenomena don't exist in nature, but if they did, building a time machine might be feasible. Stephen Hawking proposed the chronology protection conjecture, hypothesizing that physical laws prevent paradoxical time travel to preserve the universe's consistency. And that word conjecture is key. The idea is that the laws of nature are such that stable wormholes can't exist and building time machines would be impossible. If you tried to send something through a wormhole, it would destabilize and collapse. If it somehow remained stable, the question then becomes how your physical body could handle the intense stress. That stress comes from what's called tidal gravitational forces, the difference in gravitational pull across your body. This is what happens when you fall into a black hole. Before reaching the singularity, you experience spaghettification, being stretched apart due to these forces. It's similar to Earth's ocean tides caused by the moon's gravity, but in a black hole. The effect is much more extreme. However, in wormholes, according to Einstein's equations, it's theoretically possible to design the geometry so you could pass through safely without disintegration or bizarre effects. Imagine inventing a time machine and living 1,000,000 years into the future, assuming humanity still exists by then and hasn't become obsolete. You'd probably want to go back to the moment the machine was first switched on because that instant would change everything forever. That could be the true singularity McKenna spoke of. In fact, Terrence McKenna predicted the invention of a time machine might occur around December 21, 2012. There's also an intriguing story about a man who claimed to have visited the year 2345 and offered ominous predictions about what might come. This figure is known as the timeline slider, someone who supposedly jumps through time. What about the paradoxes of time travel? These mysteries continue to fascinate. As a child, Albert stood out as peculiar. Born in 1927, he had an incredible memory and was nicknamed the Walking Encyclopedia because he could recall verbatim what he had recently read. At just 9 months old, he claims to have overheard and fully understood a conversation. Before he saw the 1984 film The Philadelphia Experiment, Albert lived a normal life. He didn't see the movie when it was first released, but watched it in 1988. The film's plot centers on sailors aboard the USS Eldridge during World War II, who discover a method for the Navy to make its vessels invisible. The ship's crew mysteriously disappears and travels through time. After watching the film, Albert felt an eerie familiarity. Through experimenting with new age treatments, he began recovering lost memories and realized his true identity was Edward Cameron. Born in 1916, the people he considered parents were actually legal guardians assigned by the state. His biological brother Duncan had been kept hidden from him since he repressed his past life. Albert says these recovered memories revealed his involvement in the Philadelphia experiment. He and his brother joined the project, which supposedly began in 1931, and witnessed the experiments firsthand in 1943. The goal was to conceal U.S. vessels from Nazi detection. Notable figures involved were John Hutchinson, von Neumann, and Tesla. After success with smaller vessels in 1940, attention turned to the USS Eldridge 3 years later. On July 22nd, a major problem reportedly occurred. The ship vanished but reappeared 15 minutes later, with the passengers suffering delirium and sickness. Despite protests from John von Neumann about proceeding too soon, testing resumed a month later. Albert and his brother returned to the ship but were not aboard when it reappeared. Confused, they abandoned ship and landed somewhere neither in 1943 nor Philadelphia. Instead, they found themselves in Montauk, New York, in 1983. Surrounded by guards and helicopters upon arrival, they were taken to a secret underground facility, where they found John Fonman, who had aged 40 years. Albert said they had returned through time and learned the Eldridge was trapped inside a hyperspace bubble. As John von Neumann had revealed earlier, the bubble was growing continuously, threatening Earth's existence. To stop it, the men had to go back and destroy the ship's machinery. With axes, they destroyed the generators, allowing time to heal and return to normal. The Eldridge went back to 1943, and after destroying the generator, Al lost consciousness. When he came to, both he and his brother were in a hospital, but not in 1943 or 1983, as he expected. According to Al, It was the year 2137. While moving through time, Al says he and his brother suffered radiation burns and received treatment in this future hospital. For 6 weeks, they lived and worked there, where medics used advanced healing techniques with light and vibration energy instead of traditional bandages or creams. TV broadcasts consisted only of old programs, maps, and documentaries, and there were no comedies or soap operas. Watching TV, Al noticed that the map of America had changed. The United States had lost major territory from 2000 to 2025, with Florida gone and the city of Atlanta taking its place. He claimed the U.S. no longer existed as a sovereign state and that a global military dictatorship governed the world. Earth's population had plummeted from 7.7 billion to just 300 million, with nuclear war cited as the cause. Al says that after recovery, he tried to return to his own time but instead ended up in the year 2749, a world devastated by nuclear war, but where humanity had rebuilt into a utopia. Money and jobs were obsolete because anti-gravity technology and automation meant robots did all the work. With those needs met, war had vanished. Suddenly, Al was sent back to 1983, but his brother suffered side effects and died young. Al requested that his parents have another child, so he could receive Duncan's memories and thoughts. Duncan's telepathic abilities helped send Al back in time, with his memories wiped. Al was returned to 1927 under a different name. This story blurs the lines between fiction and reality. Conspiracy theorists and skeptics are divided on its truth. Al insists his experiences were real. He even claimed that Florida would disappear by 2025. So if true, it would soon be clear. Meanwhile, there's a bigger question to ask. Is time travel possible? In one sense, yes, everyone is traveling through time, at a steady rate of 1 second per second. Whether you're bored or wishing for more time, time keeps passing at the same constant pace. However, the dramatic time travel of TV and movies, firing up a strange device and leaping into the distant past or future, is a different matter. These stories often bring up ideas of parallel worlds or alternate histories if someone changes something in the past. Most fictional time travelers simply step into a machine and disappear, only to reappear among cowboys, knights, or dinosaurs. This is a staple of science fiction. And while scientists don't affirm this kind of time travel, they don't dismiss the possibility either. Physics might allow for some forms of time travel, though the details are complex. As yet, no one has proven a way to go back and forth in time as shown in fiction or devised a safe method for humans to make such journeys. Stephen Hawking once quipped in his writing that the best proof time travel isn't possible is the lack of visitors from the future. Still, physics does support limited forms of time manipulation. Einstein's special theory of relativity suggests that the passage of time depends on one's viewpoint. Someone moving at a very high speed will experience time more slowly than someone standing still. This idea played out when astronaut Scott Kelly aged slightly less during a year in orbit compared to his twin brother on Earth. More mind-bending theories involving black holes, wormholes, and string theory contain some of the strangest ideas connected to time travel. These concepts continue to fuel science fiction across books, movies, TV, comics, and games. Einstein introduced special relativity in 1905, a foundation of modern physics, and expanded on it later with general relativity. Special relativity describes the space-time continuum for objects moving steadily in a straight line. At its heart, the theory says there's no absolute frame of reference. Everything is measured relative to something else. Light speed remains constant, no matter the context or measurement. And crucially, nothing can move faster than light. Time travel, as we understand it, comes directly from these foundational principles. When someone moves quickly, time seems to pass more slowly for them than for someone who is at rest. On a practical level, humans aren't anywhere near light speed, but astronauts aboard the International Space Station travel around Earth at roughly 17,500 miles per hour. Scott Kelly, an astronaut, spent 520 days in space, while his identical twin Mark Kelly had just 54 days in orbit. This difference in their time spent at high velocity means they've actually aged at slightly different rates over their lives. This effect also appears in the way time moves more slowly for satellites like those used for GPS than for people on Earth. Though the impact is so minuscule that it's more of a scientific curiosity than a way to live longer or leap through time. Still, time truly does slow down as your speed increases. There's another side. General relativity says that stronger gravitational fields make time tick slower near very massive objects, like neutron stars or even Earth's surface. Time is a bit slower compared to points further away. Dave Goldberg, a cosmologist at Drexel University, explains that close to a black hole, a region of incredibly strong gravity, someone could experience just a few hours while thousands of years pass for someone far from the black hole. Coming back from near a black hole would effectively let a person travel far into the future. But heading backward in time is much trickier, even harder than surviving a black hole. Scientists have long debated the paradoxes that arise in general relativity if backward time travel were possible, and have thought up possible solutions. Fabio Costa, a theoretical physicist at the Nordic Institute of Theoretical Physics, points to early ideas from the 1920s involving giant spinning cylinders able to twist space-time and act almost like a straw rolled between your hands. It wasn't until the 1970s that this concept was proposed as a way to turn such a device into a time machine, making use of something called closed time-like curves. A closed time-like curve is a path through space and time where, from one zone perspective, you always move forward, but eventually end up back where and when you started. This is possible if gravity twists space-time so much that it loops back on itself, though it remains speculation. This idea spurred further scientific inquiry. In the 1980s and 1990s, more researchers, including Russia's Igor Novikov and American Kip Thorne, explored the mechanics of time travel and what constructing one might involve, as well as the challenges and paradoxes that could arise. A popular thought experiment considers sending a billiard ball into a time machine. If it went into the past and knocked itself away from ever entering the machine, the situation creates a paradox. Since the 1990s, interest in the topic has waxed and waned. But every model of a time machine so far has run into serious issues. Each idea seems attractive or promising at first, but there's always a major stumbling block once the details are analyzed. Much of this comes back to Einstein's finding that mass and energy are interchangeable, which implies that most time travel theories would require negative mass, and so, negative energy. Like electric charge, mass could in theory be positive or negative, but scientists have never observed anything with negative mass. Negative mass or energy is often proposed as a way to keep wormholes, hypothetical space-time tunnels, open. Without it, the intense gravity would crush the tunnel closed. Negative energy, in this context, counters the effect of positive mass to hold the wormhole open. Both Khanna and Goldberg agree that negative mass matter most likely doesn't exist. Yet Khanna notes that quantum physics allows for negative energy at extremely small scales. He claims that an actual time machine would need much more. Some have theorized about wormholes or cosmic tubes linking distant locations like a shortcut through space and time. Imagine sending one end of a wormhole to the past by moving it at near light speed, while the other end stays put. This would split their experiences of time. Travel between the two would result in time travel. Another approach is placing one end near a massive object like a black hole, and leaving the other in a weaker gravitational field. Time at the massive end would slow dramatically, so an object moving through the wormhole could come out in the other's past. Creating such a wormhole, though, would demand negative mass and energy, and any attempt to do so with regular matter would quickly fail, as gravity would collapse the tunnel almost instantly. Many of these designs run into similar issues. They work in theory, like a pizza with no calories, but can't be made in practice. Maybe, as the late physicist Stephen Hawking suggested, the real obstacle isn't only that we lack know-how, but that constructing a time machine is fundamentally impossible, except perhaps at extremely tiny scales. In a 1992 Physical Review D paper, Hawking proposed that some sort of chronology protection agency exists in nature, one that blocks the formation of closed time-like curves, keeping the universe safe for historians. His reasoning partly centered on contradictions that time travel could cause, like the billiard ball scenario or the classic grandfather paradox. If you travel back and kill your grandfather before he has children, you could never be born. So you couldn't have gone back to kill him, but you still exist. Agustin Rio, a philosopher at MIT, is interested in these tricky issues because they involve more than causality and time. They challenge ideas about free will. If physics allows backward travel in time, why are you unable to kill your own grandfather? What stops you? Are you somehow not free? Rio suspects time travel and free will might be compatible. He reasons that the past is fixed, so if your grandfather lived to have children, then leaving the present to attempt to change that won't alter history. Why would you fail? Perhaps simply because the details of the past are unknown. But you would fail. And for reasons as mundane as missing the bus or an accident on the way. Ultimately, the future of true time travel remains unresolved. And so far, no future visitors have stepped forward to reveal its secrets, aside from stories like Albec's, which are still unverified. Is it possible people from other times walk among us? The question remains open. And it's just one of a countless number of mysteries that inspire continued curiosity and imagination about space and time.